Yes, I can see it.
Beautiful. So what is written there? What can you read out of it?
8, it says 8 at the top, project quality.
All right. That is nice.
It says management, project quality management. Yes.
Okay. Yeah, exactly. That's what I want you to see. All right. I'm going to give the opportunity to one of those that are joining us today to just tell us the reason why they are in the class. Ibrahim, Kadiri, Timothy, any one of you can unmute and just
Yeah,
maybe. All right, who is speaking? Is it Ibrahim?
yeah. Good day to you, sir.
All right. Good day, sir.
So I'm Ibrahim Adebayo from Nigeria.
Okay. So,
I recently completed a course on product management. So, in some aspect of the role of a product management, I was told we can equally work or learn more about project management, that they are interwoven, that we can always switch in between. That is why I believe if I could add the project management to what I've just what I've just concluded learning as a product manager, I can always switch career and I can always blend to use some tools that are essential and are common between both product and project management.
okay. Yeah, that is nice. That's a good one. That's a good one. Product management has a limited scope because in project management, we talk product management and we talk project management. We have two kinds of scope.
Yes,
Here we have the product scope and we have the project scope. So we use the
yes, sir.
product scope, we collect requirements about the product scope to come up with the project scope, and we use the project scope to create the product. Yeah, I think you are at the right place. You're not only looking for a knowledge that can help you perform well as a product manager, you would be getting project management knowledge also. So you have two hats. Yeah. Okay, that's nice. I'm going to take just you today. Um, Timothy and Kadiri, don't worry. We can talk some other time. Time is fast spent. Well, we've already lost 26 minutes or 27 now. So today we want to talk about quality. Very important, quality. Every product, every project must have a scope. And the scope of the project must be within requirement, within business objective, just as how the customers would want it, just as how the sponsors would want it, should be given for acceptance. Creating what the customers expect us is quality. Quality is customer satisfaction. Quality is zero defect. Quality is fitness for purpose. Quality is continuous improvement. You see? So how do we now manage this quality? How do we manage this quality when we are on a project? It will first of all start by we understanding what quality is all about. And what is required of us to manage that quality, that given quality. How do we even choose the right quality? A particular quality that could have been chosen may be unrealistic. So if we are not trained on how to desire quality, we may just be dreaming unendingly. So project quality has to do with the process and activities of the performing organization that determine quality policies. So the quality policies, objectives, and responsibility that the project will satisfy the needs for which it was undertaken. All right. We must satisfy the needs for which our project is undertaken. So we use, when we put together policies, we're talking about policies that will enable us implement quality management system and ensure that as we embark on the project, we keep getting better by the day. These are policies that will enable us improve on our pieces, improve on our knowledge, improve on our ability to do the right thing at the right time. That is quality. Quality is doing the right thing at the right time. And now we have three processes that will enable us carry out project quality management. The first one is plan quality management. The second one is manage quality. And the third one is quality. Yeah. Like, you know, for everything we do, we always come up with a plan. So plan quality management will give birth to quality management plan as our output. So when we plan quality management, we are trying to identify the quality requirements. We are trying to identify those standards for the project and the standard for the product, and ensuring that we have them documented. These documents would speculate how compliances can be achieved. This is what the project quality management plan would carry. Having gotten the project quality management plan, we move on to start managing that quality. In this area, we are talking about auditing the quality requirements, you see, and the results from quality control, just to ensure that we have selected the appropriate standards that would be necessary for the right quality to be given. So when we manage quality, we only manage quality during the executional phase. Like we know, we have 5 major processes. We have the initiating, we have the planning, we have the executing, we have the monitoring and controlling, we have the closing of the project or rephase. So this takes us to control quality. This is the process of monitoring and recording results of executing the quality activities to assess performance and recommend necessary changes. When you hear the word control quality, now the job is ongoing. We want to ensure that everything that is being done as regards quality is in line with the quality management plan. And you know our culture, if a change is being observed, we must ensure that we analyze the change to come up with certain justifications that will be passed on to the change control board to analyze, either approve of the change request or reject it. If been approved, we go back to incorporate it in the quality management plan aspect of the project management plan. The quality management plan is a subsidiary of the project management plan. Changes are inevitable, as you know. So now let's dive in and let's now start talking about them one by one. Project quality management addresses the management of the project and the product of the project. Okay. So here now, I have it written that product quality measures, a project quality measures and techniques are specific to the type of product by the project. That is to say that there is no single yardstick that should be used in measuring project quality. There is no single technique. Everything we do as regards quality must be contextual. That is talking about the kind of project in hand and the environment, the peculiarity of our environment. We must ensure that our tools and techniques are tailored towards giving us the right quality. Yeah. Yeah. Okay, I'm going to be introducing two terms. The first one is quality, like you know, grades. Sometimes we use them interchangeably. Some persons would feel quality is the same as grade. Now, quality has inherent characteristics. So the degree where which we fulfill these inherent characteristics is described as quality. Whereas grade is just a category assigned to a product or services. In a single grade, we may have different kinds of quality. So, say a grade is a category assigned to products or services having the same functional use, but different technical characteristics. Different technical characteristics. You see that difference in the technicality would be speaking about the different kinds of quality. While a quality level that fails to meet, while a quality level that fails to meet quality requirement is always a problem, low grade may not be. Because in a low grade, you can still have the best quality amongst that grade. But wherever quality is brought into the description, if you're not hitting just that quality, you are off or below, you are over or below, and we don't want to give extras. We want to ensure that we give that which we are being contracted to give. Though we may come up with a more stringent way that would enable us give the customers or the sponsors that which they want us to give to them. That is just more stringent way to ensure that we give out the right quality. So when we talk about quality management, we have to think about what is required for failure, how much it will cost us if we did not get the right quality. That becomes the cost of quality. And how much we could have saved if we get the right quality. That's also the cost of quality. Yeah. So like I promised, I've been given out this material, but I could not drop it. But I think I will share it this evening. So I haven't talked about quality and grade. Let's take a look at an example. Say the software product can be of a high quality, no obvious defects, and low grade, that is a limited number of features. Or low quality, many defects, poorly organized user documentations. These are examples. And high grade, numerous features. The project manager and the management team are responsible for managing required levels of both quality and grade. So this brings us, we are trying to set the background for quality. We've not started talking about quality. I'm just trying to see how we can introduce it. So precision and accuracy are two terms that we should be aware of. When we say precision, it means the values of repeated measures are clustered and have little scatter. For instance, we have number 4 on a scale, and the owners want us to ensure that a particular feature, the quality of a particular feature is around number 4. So everything we do must be within 4. The scale of 4 could be within 4. Like 4.2, 4.11, 4.3, 4. These are still within 4. So as long as they are within 4, they are acceptable. They have good precision because 4 is the benchmark. Even 3.99 is still within 4. But if we do not understand what precision is, and we start designing, we may be thinking, because we have 4, and the next number becomes next measurement we had, or next product that we turn out, next deliverables that was turned out went to 5, we would be thinking, yeah, 5 is still close to 4. But it's just a difference of 1. Yeah, it's still okay. Okay, we now accept 5. What will happen when the next deliverable records or scales 6? Still 1 away from 5, but 2 away from 4. You see how off we've gotten. So that's why we must understand the concept of precision and accuracy. Accuracy may mean that the measure of value is very close to the true value. Precise measurements are not necessarily accurate. Okay, I think I'm juggling it. Let me change it upside down. The explanation went the other way around. Precision is when differing values would have the same number of differences. Like we have 4 as the initial value given to us to design to. Then the next figure got to 5, another one 6, another one 7. Precisely, they are increasing. You can see that the differences are just 1, 1, 1, 1, 1. But using precision and accuracy is very important, because when we choose the benchmark as 4, we wouldn't want the numbers to be far away. We want it to be around the true value, which is 4. So anything we have that is around 4, because we will be measuring them from 4, we should be able to summarize it back to 4. That is about accuracy. That is about quality. Quality has scales of measurement. Maybe you want to measure the quality of a gold, the quality of a particular component. There must be a true value that should be benchmarked if you really want to record accuracy. Because at the end of the day, the performance would give you a kind of result, and that is what will lead to the acceptance of that product or deliverable. So accuracy means that the measure value is very close to the true value. Precise measurements are not necessarily accurate. Like I said, a very accurate measurement is not necessarily precise. The project management team must determine appropriate level of accuracy and precision. Both quality management and project management recognizes the importance of customer satisfaction, the importance of prevention over inspection. I would explain. So this is what we must have in mind so we can carry out this. Once you have the understanding of customer satisfaction, you would know when a precise measurement is taking you off the true value. Understanding is needed when it comes to customer satisfaction, and customer satisfaction is quality. So we must understand the customer's requirement. We must evaluate the customer's requirement. We must define and at the end of the day, manage their expectations for our products, our deliverables to be accepted at the end. When we talk about customer satisfaction, we could be talking about conformance to requirements. This is ensuring that the project produces what it was created to produce. Yeah. And the product is satisfying the real needs. Remember, we have the project objectives. These are the real needs. These objectives that were found on the business case. Must be met. Then another one is prevention over inspection. There are times that you may be tempted to finish up before you go and check if what you have done is in line with what they want you to do. And you keep going on and on. But here now we are learning that prevention is better than inspection. So you design and come up with measures that will keep the wrong things, will keep failure away from your project. Keep failure, keep defect away from your product. You also come up with measures. You invest in measures that would keep errors away from your work. You see, one of the fundamental tenets of modern quality management states that quality is planned. Quality is indeed planned, quality is designed, and quality is built in, not inspected in. Not that when you are done, we'll not bring out the measurements, the yardstick, and now start measuring it. No. We must ensure that as we are even designing the components of the component that makes up the total product, we are using specifications to design them. We are using specifications to even assemble them. The next one is continuous improvement. And we have this word called the plan, do, check, act cycle. And this is the strategy for quality improvement. Plan, do, check, act. You plan, you execute, you check if what you have done is right. If it's not right, you act. Ensure that you're expunging that error from the product and you're replacing it. And you go back, and then till the final product, it's been delivered. When you read on your spare time, if you would have the chance, I encourage you to read. There are other things you may be learning that are found within my text here. So management responsibility is encouraged in the design of quality. When we talk about quality, it's not like management coming up with whips and talking to everybody, flogging everybody to want to do the right thing. Management must invest into what they preach. Management must create the enabling environment. Management must provide the required tools for their desired quality. Success requires the participation of all members of the project team. Yeah, but remains the responsibility of management to provide the resources needed to succeed. This brings us to cost of quality. Like I told us, the cost of quality refers to the total cost of all the related efforts that would enable us satisfy the customer. These efforts that must be carried out through the product life cycle, through the project life cycle. And remember, every project decisions made will reflect in the quality. And that's why it's good we gather data so we can come up with informed decisions. There are certain decisions you will make in the design of a product, and that decision may, at the long run, reduce the operational cost of that product or increase the operational cost of the product. When we put together, when we use quality materials to build a team, you know that maintenance cost during the operational phase will be minimal. A product with low quality will call for maintenance every now and then. Yeah. This is very important. And that could lead to lots of other damages that we could be paying for. Even the cost of rework, for you not to be able to do it well, and the customer is coming to say, redo it again. That is additional cost. That is part of the cost of quality. The claims, the recall campaigns. I was told several years back that there was this product. I believe some of you could have been more aware than me about it. A particular phone, is a phone or a car that was released, and they discovered that the quality was either low or it was causing damages. It has some security challenges, and the organization had to now start calling them back. Who knows this story? Is there anybody here that knows about it? Yeah. Any product that had been called back by the company that you are aware of, you can kindly unmute and share with us.
Like Lacasera in Nigeria, there are some moments ago. Lacasera is a soft drink product.
Yeah.
So sometimes ago, some people realize that when they pour Lacasera drinks on some boats and screw, it do lose a rusted boat that is not ideal for the heart. So immediately they devalue the product. People begin to stop buying the products, which the company later stopped producing it.
Okay. Yeah. I'm not aware of that, but thank God you know about it. Now, Tolu is saying that it sounds like the Samsung phone. Yes, I heard about the Samsung phone. Was there a time, right? They called already produced and already bought Samsung phones, right? I heard about it somehow.
Yeah, I believe at some point they were the phones were catching fire, something dealing with the batteries causing an issue.
Oh, that could have been so expensive because they're going to be paying damages, right?
Exactly, yes.
So that's the cost of not getting the right thing done, the cost of not designing the right thing. The cost of not building the right thing, that is the cost of quality. How much it will take from you, the delays, and how much it will bring to you. That is the cost of quality. So you have to see quality from these two ends. Cost of success and cost of failure. So now let's take a look at the plan quality management. Like I said, it's the process of identifying the quality requirements and standards for the project and its deliverables, and documenting how the project will demonstrate compliance with quality requirements. And the key benefit of this process is that it provides guidance and direction on how quality will be managed and validated throughout the project life cycle. And you know that's what a plan will do. A plan is a guide. Yeah. It's a guide. So what do we need to come up with this plan? We need some inputs. We need some documents. We need to see the project charter. The desired quality ambiguously is described in the project charter. And from all the requirement gathered, like the requirement documentations, the requirement traceability matrix found in the project management plan can enable us come up with the right plans to plan for quality. That every project document should be gathered and analyzed. Enterprise environmental factors are very important, and also the organizational processes. So when we say enterprise environmental factors, as we talked about quality, let me see if I have it here, because I think I never wanted to overflog that here. I took it out. So the enterprise environmental factors, you know that there are some products that would not be allowed to be produced in some countries, and even if you produce them elsewhere or you produce them in that country, you can take them out to other countries. Those are the country laws. What the government will allow, the standards in the industry, what is required, the kind of materials that are allowed to be used within that domain. So we need to know that, or else you'll be turning out a product that will lead to sanctioning. We design quality too, and most times quality is benchmarked. That is conformance specification. We got two types of conformance and two types of specification. If you've been a project engineer, you would understand that. Two kinds. We have the performance specification and the conformance specification. The performance will be speculating the functionality of the product, what the product should be able to achieve at the end of the day. What can the product do when we are done creating it? What can it do? How would they perform? That is performance. But conformance, it's like the product owners, that is the investors, the sponsors, they have something in hand and they give it to us. Say, we just want you to build this thing for us, exactly what you have in here. Mimic it and give us exactly. So, but when the place where performance specification is given to you know that we can freestyle, we can innovate, come up with our own strategy, and even reduce some cost, remove some functionality. But at the end of the day, the machine will perform the same way and give us the same result. With less cost, we can do more. Why? Maybe because we have a higher component inclination. Maybe because we have better equipment when it comes to designing and building. It allows the project manager and his team to innovate, to be creative, the performance specification. Anyhow you want to do it, go and do it, but ensure that what you have done could get this and this done, could give us this kind of, should give us this kind of results. That is performance. But conformance, everything you do must be this color, whatever, let it be just this. Now they give you a sample. So you must understand what is needed. That's where the enterprise environmental factor, even on the organizational process asset, there are tools that are needed for quality management. Your organization may or may not have the right processes put together that can enable quality management, even though to plan quality too. How do you plan it? So where are the tools? We need experts, people who can understand quality. That's where the expert judgment comes in. And these experts, we're not talking about expatriates, other country nationals, no. We're not talking about just that. Maybe other country nationals, we are just talking about people who have interact with that, with the product somehow in that domain, who can enable us cut down on our time and satisfy the customer's expectation. So we gather all this data from the project charter, the data from the project management plan, the data from the project document, and the enterprise environmental factors. We put together our organizational process asset, our organizational process assets are those softwares we have in our organization that are enabling us to analyze the data. You can speculate trends, how errors can be found in your product, what should be done for you to get good results. And we haven't seen that. You come up with an informed decision. So decision making, you sit down and you analyze options and you choose the meat. Say the meat. And sometimes when we talk about quality, it could be that we as project managers, we are on top. We are putting together a team of subcontractors that will deliver quality for us. With this knowledge of the meat, when I say the meat, you may want to write it down on your book, MEAT. I'm going to explain it. These are part of the extras that I want to give to you tonight. Meat. You know, sometimes when I talk about these things, it's high me, okay? It makes what I'm turning them to be. You see what I'm giving them? They all have a bowl full of chickens and you just name it, beefs. So the meat, when we carry out bids and bid evaluation, the strategy we use is the meat. The meat, MEAT, signifies the most economical, but yet advantageous tender. We are not looking for the most economical, but disadvantaged tender. These contractors, these subcontractors that are coming in to maybe execute an aspect of our project may be looking for ways to wow us with low cost. They wouldn't know that we are trained and we have a yardstick of measurement called the meat. So amongst all the bidders, we want to see the bids, the contractor that can satisfy the meat, that has the most economical. When we say most economical, the strategy that the contractor is using that will cost us less, talking about materials, equipment, and financial, but yet the product that will be gotten from it will give us certain advantage, not a disadvantage. You know, sometimes the untrained procurement professionals, contract personnel who feel that the cheaper the better. So they now start looking at the particular bidder that is promising a low cost. Like I told you, it's good you spend money in designing, you spend money in building, and you spend less in maintaining. Yeah, today you've added meat to the portfolio of knowledges which you have. This same thing we do when we want to analyze the total cost of ownership of acquiring a product. When we want to analyze the total cost of ownership when we are embarking on a project. When we want to make procurement of some capital product, we must understand the total cost of ownership. The total cost of ownership is a strategy we use to ascertain the life cycle cost of owning that product. Now, a particular supplier or a particular vendor could have promised you that his own product costs certain amount, maybe $10 million. I haven't looked at it against the others that are $15 million, $30 million. You'll be like, wow, this is so beautiful. Just $10 million, and then this product will be shipped to my property land. Said yes. But you wouldn't know that that vendor could have had some hidden cost, even buried in the maintenance. That every three months, he would be flying personnel from their organization into your own country or property land to maintain that product, or else you would not be able to use it. And each time they come, you will spend additional $3 million. Can you see the hidden cost? The cost of maintenance is high. What about the cost of decommissioning? The cost of inspection, the cost of installations, all these costs sometimes may be hidden. So when you're making your decisions and you're looking at all these documents, you may be looking at because we will get to the project procurement management, where we'll be talking about all these things, and so you can understand them better. So you use all these to make your decisions, like I said. And at the end of the day, your data must be represented by the kind of decisions made, and people should be able to look at it and have a kind of understanding of what those data are talking about. So we must test quality as part of the tool. We must inspect the planning. Once we have all these things done by meeting with one another, our output will become the quality management plan. We cannot make decisions of what we should do to ensure that customers are satisfied, what we should do to ensure that we come up with a product that serves his original objective. Then there must be matrices when we talk about qualities, things that we would measure, things that we want to see to say that, wow, this is satisfactory. Then now that you have the quality management plan, remember the quality management plan is a subsidiary of the project management plan. That is why you see on red, number 3, the project management plan updates. The project management plan is updated because quality management plan has been added onto it. Then on every document would be updated because we have a new knowledge in town. Yeah. So how do we gather data? Like I said, we benchmark. We're comparing actual or planned project practices. You brainstorm. You may even be interviewing some experts. When we talk about data analysis, you remember the myth I told you about total cost of ownership, total life cycle costing. You're looking at the costs and the benefit. That's what you're analyzing. That's what you do when you come up with the most economical and advantageous tender. You're looking at the tender that is most economical and at the same time is adding more value to the performing organization. So you're looking at how much will I invest in this product and how much will I be getting in return. And when you are talking about the cost benefit, I need you to see things from two highs. One, tangible benefit. Two, the intangible benefit. I think I'm giving you so much extras, and that's why the class is moving too sluggish. Let me save this one for another day. Let's move on. Except somebody want to say, please, please, please come back with that. Come back with that. I'm enjoying it. Don't cut it short.
We're still with you now.
Come again?
I said, we're still with you. Continue.
You see, you just, you're making me to feel like, yeah, one senior lecturer somewhere that has professorship in 6 areas. Okay, so that's about that. When we talk about the tangible benefit, we're talking about the financial benefit. If we place or put down this amount, how much will it give to us? How much would we get in return? Here now we're talking about return on investment. Then the intangible benefits are those strategic goals that can give us certain advantages, but may not be financial at the point where which the product, the project is being carried out. But in the future, they will give us, bring money into our pocket. Those intangible benefits may be brand recognition. Those intangible benefits may be that our team members would now know how to fix certain things and satisfy customers better. If that may be the only benefit we will get from embarking on a certain project, it's still okay, because at the end of the day, we will have the right inclination to compete very well in our industry and claim a higher market share. So if we speak on quality, we would just rather say the primary benefit of meeting quality requirement can include less rework, higher productivity, low cost, and increased stakeholder satisfaction. Increased stakeholder satisfaction, is it tangible or intangible? From my explanation, what would you say customer satisfaction is? Is it tangible benefit or intangible benefit? Don't worry, just give it a shot. I'm always here to help.
Sounds tangible.
Okay, tangible, right? Yeah, I really believe it's tangible, but at the long run, when the customer comes back now, we can now, increase our prices because they have tested of what we served. But at this point, I think we should see it as intangible because it cannot be quantified. It's not financial benefit it's bringing in. But at the long run, it will still bring money. Once the customer satisfaction, it may be difficult to quantify. You know why? Because it is the customer alone that say, oh, I'm satisfied, I'll come back again, or I'm not satisfied. Even when another customer somewhere is satisfied with the same level of service, a particular customer somewhere will feel, I can give them 10 over 100. I think that kind of customer only knows what he wants. That's why they say what you want is not in this world. Have you been told that before? So we have the cost of quality, like I say, includes how much you put on ground to prevent the cost, the appraisal and the failure. And when we talk about appraisal, it could be internal or external cost. Cost of quality includes all costs incurred over the life of the product by investment in preventing non-conformance to requirements, appraising the product or services for conformance to requirements, and failing to meet the requirements leads to rework. And we don't want rework. Failure costs are also what called cost of poor quality. Yeah. So do we have new terms here? So when we now start looking now, let me take you to this diagram. If something is showing here, we're talking about plant quality. So I want to introduce us to about 7 tools that could be used. I may not, because of time, I may not explain them in detail, but I may pick one of them. We have these 7 basic quality tools, includes the control chart, the cause and effect diagram, the flow chart. All these are charts we use, check sheets. We have the Pareto diagram, we have the histogram and the scatter diagram. Now, these tools are very important, very, very important. We use them in setting the quality standard, and also we use them to also measure quality. We also use them to monitor and control quality. Like now, we can see on your screen, control chart rather is showing, say control charts are used to determine whether or not a process is stable or has a predictable performance. You cannot look at the process and the way things are going. The control chart can enable, can even speculate, can forecast what may likely go wrong. Now the control chart has what is called the upper control limit and the lower control limit. And this is what we use in coming up with the specifications. It has the upper and lower specification limits also. Now let's come in here now. I'm going to be explaining this one in detail so you can see. Can you see my diagram? Now, I haven't looked at my diagram. There is a line, a thick line in between, which is at 12 inches. This 12 inches is the mean for the product that we want to turn out. The customer had told us that anything around 12 is okay. So that's how when you look at it, we have 11.90, we have what? 12.10 here. Now, when you look at the diagram, you will see that the upper specification limit is at 12.10. So look kindly on mute.
Yes, sir.
All right, beautiful. I need you to correspond with me. Okay, let's go. Can you see the upper specification limit? 12.0, right? 12.10.
Yes,
Okay, so now the customer has said the measurement when you are done, when we measure the quality, it should be between 11.90 to 12.90. Any area, any place within this boundary is enough. So this is the specification given to us. And yet the customer told us that their desired specification is 12, which is the mean, right? So any figure turning out, any measurement turning out within this is okay. So the project started from 0.0 now. The first one we got was 12.01. We went on. The second measurement was 12.02, beautiful, and is within the mean and the upper specification limits. It's still okay. So as long as anything we are doing is within this boundary, the customer will accept it. The product is satisfying their needs. But you know, you and I, as a project management professionals, we are very much intelligent, and we looked at ourselves and say, why not we come up with a kind of more stringent specification that will not even, that will enable us not to even get close to that upper specification limit, because if anything happens, we are dancing around it, we may likely fall off it. So why not we come up with a more stringent specification, and this becomes the upper control limit and the lower control limit. We now give ourselves what? We gave ourselves 12.09 and what? 12.9. Okay, where is it? Where is the lower control limit showing here? Okay, this that is showing here becomes our lower control limit. You see, 11.91 is our lower control limit, whereas their lower specification is outside. So we want to check ourselves even more stringent than what. So peradventure, we have subcontractors that we want to give this job we have gotten from our major contractors. We have to give them this lower control limits. So even if they are making mistakes, it will not fall off what the owners want us to do. Is it clear? I'm not done here too, but can you understand what I'm explaining, what the control chart is enabling us to do?
Yes.
Now, having said that, this is what is called the rule of 7. The rule of 7 says that if you consecutively record a point within the mean and either the upper limit or the lower limit 7 times, there must be an assignable cost, which means something is wrong. Can you see how it's going now? Something is wrong. So you must stop to reanalyze and investigate what is causing that. There must be a condition that has kept it there. Because you want to be able to control what you are doing. So that is about the control chart. I know in this class, you don't need this specifically because this is a machine. You don't need it, but sometimes you need a transcript of certain things that are being done in the industry. You need the nativity of certain things that the machines are doing for you. That's how I had to explain it. There's no time. If in an interview, what they will just ask you the kinds of tools that are used in, can you tell us about the tool you have used before in managing quality, where you talk about the control chart. But now I'm going to talk about 2 more before we move on. Which other one should I talk about now? Which other one? Okay, let me talk about the cause and effect diagram. The cause and effect diagram, also known as Ishikawa, another word, fishbone diagram, illustrates how various factors might be linked to potential problems or effects. You have a recurrent value. That is to say that that value is caused by certain factor. That is what it's saying, certain factor. For instance, I'm going to use a different analogy. A security personnel was hired, and yet they could still find things missing. The first thing that somebody will say is that the security man is not doing his work right. Okay, and now you now start talking to the security man and you say, you're not doing your work very well. If you try this, you will be sacked. That may not be the cause of the theft. The next thing is to ask, why is the security man not doing his job very well? Oh, we discovered that he's coming late every morning. Oh, what is making him come late? Oh, where he's staying is far. But why can't he just stay somewhere around the company so he can get to commute to job rather easily? You now discover that the salary you are paying him is not even enough to have a property, to hire or rent a property within that community. So he had to go to the outskirts of the town, and before he could catch the train and come to work, others that stays around could have gotten to the office and they could have stolen. So now you now understand that the problem is not the security man. The problem is either you not paying him well, or two, for you to solve it, you must want now to build an apartment somewhere close to the company if you want to eradicate that problem. You now see that that is a cause and effect. So once you eliminate that by providing an accommodation somewhere around the company premises, you have taken care of that. So there are certain decisions made about quality that will give birth to certain other things that if we cannot ask why is this thing happening? Why is it happening? Like down to like 6 to 7, 5, 4 times, we may not get to the assignable cause. And another thing to ask aside the why is the how. So the cause and effect diagram is the why diagram, is the how diagram, is the what diagram. What is causing this thing? You ask what enough till you get to the cause. You ask why it's so much that you get to the cause before you stop. And this is what is called the root cause analysis. I'm going to tell you an history about this root cause analysis. Please just give me a minute. Let me, that light we were looking for is back. Let me power my laptop. I told you the light is back. Yeah. Okay. All right. So that's about that. You can understand that. So this is the cause and effect diagram. I told you I was going to tell you a story. 2008, I read this. I visited a brother in his office, and he brought one document, just one page document, and I read this cause and effect diagram. And I understood this why on that. I visited him in his office, so I read it. And the next week, I was invited for an interview, and then I asked, so if we bring you in, what advantage are you coming in with? When you're a fighter and you have only one strategy, you must ensure that you create an advantage that if you're releasing that blow, it will really hit his target. as they said that, all I could just remember was the cause and effect diagram. I said, I understand root cause analysis. And I started explaining what I've explained to you. And I was telling them like it's what I've been doing all through my 88 years of life. And at the end of the day, one white American lady, Leah Kilpatrick, she now said, wow, you are hereby hired. This cause and effect diagram. That was the first time I came across it. Okay, so that's about that. Others are here. When you read, they are not, we've explained them somehow, but you can read and understand. So this leads us to the managed quality. When the plan is out, the managed quality is the process of auditing the quality requirements and the results from quality control. Please, we must finish this chapter before we close, okay? The next 15 minutes, we should be through. I've been laying the foundations. So the managed quality is the process of auditing the quality requirements and the results from quality control measurements to ensure appropriate quality standards and operational definitions are used. You see, quality is an execution process that uses data created during perform quality control. So what are our inputs? The first is the project management plan. And in the project management plan, what would you need? The quality management plan and any other document related to it. We now have the project documentations, all of the documents. We have the organizational process asset because we could be using these 7 tools, either of them, to conduct this in our organization. There might be templates for checklist, check sheet, templates for carrying out root cause analysis, and all these are needed here. So the data, we gather data, we analyze the data, we make decisions, and we now also carry out audits to audit internally what we have done before the customer or the client would come and audit what we have done. So we carry out internal audits. And there is another word here, designed for X. I'm going to explain what that is. For instance, we are coming up with a car, that's what we are designing, and we are building it. Do you know that everything planted in that car should have what advantage or disadvantage they will give to us, the owners? Some persons may just like our car, maybe because of the car headlamp. Some persons may like it, maybe because of easiness of maintenance. Some persons may like it because of the color. So when you are designing, you want to ensure that those things that will give you the expected, help you to capture the expected objectives, are designed into your product through your project. That is the design for X. Yeah, our output is the quality report, because here now we're already managing quality. We carry out test and evaluation. If we are not meeting up, we come up with a change request, and the project management plan would be updated because there is a report about quality right now. So that is that. If we have to analyze, what data are we analyzing? We are looking at alternatives. What are the varying ways we will use in getting the same thing done? How do we not satisfy the customers and with less cost? Like I told you, we have 2 kinds of what? Specification, conformance and performance specification. If peradventure the specification is what? Performance, we can now come up with alternatives. We analyze alternatives and check if we can meet their needs by doing things differently. We have the processes, that the processes must be analyzed, because how do you get quality product? First, you design. Second, you get good processes. Third, good components. When you assemble all these three together, you cannot have good products. So that's why you analyze the process. And when you analyze the process, you want to identify opportunities for continuous improvement, opportunities for the process improvement. Design for X is here. It said this is a set of technical guidelines that may be applied during the design of a product for the optimization of a specific aspect of the design and can control or even improve the product's final characteristics, direct aspects which may result in cost reduction, quality improvement, better performance, and customer satisfactions. You see, these things, the kind of advantage you want should be designed in. And customer satisfaction includes reliability, deployment. Easy deployment is important. There are certain products you will design, you cannot deploy them. When we say deployment, it may be that we want to run them on a particular system. Some softwares, once been designed, the easiness to run them on existing products, on existing computers may be difficult. What are the usability or the safety too? Is safety built in? So certain times we need to know how to solve problems.